afternoon, everybody. I'm Dan Helton, and if you're here today, you're here to talk about mainframes. I apologize for the bit of a color problem here on the display. If you're watching this on YouTube or archive.org later, then you probably don't have this problem, but hopefully it shouldn't impact the presentation too much. A little bit about myself. I'm a senior security consultant at NCC Group. I mostly do web apps, network pen testing, red teaming in my day job. I'm a bit of a nerd for odd, esoteric computers, like history and things like that. You can catch me on Twitter at ch1kpwe, or that's also .com is also my website. This presentation is on here. I promised this the last time I gave this presentation that I'll eventually write a lot of this stuff up in blog post form. Still working on that. But hopefully I'll codify it a little bit so it'll be a better online reference. I got a lot of material to go through, so I apologize if I'm a little fast. It's a big brain dump to go through here with all this mainframe stuff, because it's something that most people in this room probably don't have much of a background in. So first off, what is a mainframe? It's helpful to actually define what that is. So it's almost always IBM Z hardware. It's not just any old clunky old dinosaur computer. That's one thing to get out of your head. It's a very specific class of computing. There are still a few competitors like Unisys and some other people in that space, but IBM absolutely dominates nowadays. So it almost always means IBM Z hardware, and almost always means ZOS. There are a couple other operating systems that IBM supports for their Z architecture. I'm not going to go into those. I'll just stick to ZOS. Kind of the defining characteristics of a mainframe are that it handles enormous volumes of input and output. So these things are made to tear through millions, billions, trillions of transactions. That's why they're the backbone of banking. I mean, if you used a credit card or an ATM today, you used a mainframe indirectly, because your transactions are all being processed through there. Another key of the mainframe is that they're built for RAS, reliability, availability, and serviceability. So these things are built like public utilities almost. Like they are meant to stay up 24/7. 99.999% uptime is very important to the mainframe business. They are built for pretty crazy backwards compatibility. They are heavily batch-oriented. So the idea is you build these complex batch jobs. JCL, job control language, is like one of the big scripting languages in the mainframe world. You build these big complex jobs to, like I said, take in 1 million credit card transactions from a day and then go process them and spit them out the other end in some kind of format. And to do it all in a very complex way that handles all sorts of variables and all sorts of contingencies without a human having to jump on and interact with it. They are always mission-critical business systems. That's why companies still pay millions of dollars to IBM every year to maintain these things. They are always at the heart of the business. And one quick note, because I know some people here probably came thinking about AS400s. One, that they have not been called AS400s since, I don't know, the crew of MASH was making commercials for them in the 80s. So I've seen those on YouTube. The proper name is the IBM I platform. It's not actually a mainframe. It's what's called a mid-range computer. It's kind of like the next tier down. I've hacked on them. There's a lot of good stuff out there, some good tools for them. But they're not really considered mainframes, and they're not in the scope of this. So the biggest thing you hear when you tell people about hacking mainframes is, mainframes are legacy, right? Oh, why do I worry about mainframes? They're going to get retired next year, right? The thing is like in the 90s, the mainframes really got hit hard in the market when cheap Windows and Unix and Linux servers were, starting to eat their market share. So in the 90s, a lot of people thought mainframes were going to die, but e-commerce saved them, and they are still with us today. Seriously, IBM still makes a couple $1 billion off these things every year. They're not going anywhere. They're still big in finance, air travel, insurance, government. They're still actively supported, actively maintained. They can even run modern stuff. They can run SQL. They can run web applications. They can do Java stuff. But yeah, you do also still see stuff like batch jobs that were written in the 1960s, because that's part of that backwards compatibility. It's stuff you wrote in IBM System 360 assembler in 1968 should still be able to run on a modern mainframe with little or even no modification. And they're also pushing it in other places. They've tried to push ZOS hard for cloud computing, for blockchain, all the trendy stuff. ZOS can be very conservative in its design and style, which I think you'll see when we do some of the demo videos. And it does have insane backwards compatibility, but don't confuse that for legacy, because this is an actively updated and maintained platform. So when you think of a mainframe, this is probably what you think of, right? Like reel-to-reel tape, like something on my shirt here. Then that's a 1960s mainframe. That's a System 360, one of the first. This is actually a picture of my great aunt. I believe that was with the Arizona Highway Patrol then, and they actually had a small mainframe installed. But this is what they look like nowadays. You see here, they look like a giant gaming computer. It comes across. I like kind of like the angles and blue lights and stuff. Seriously, they look like a giant gaming PC. And these things are like monstrous. Like you buy one of these things, like you see, it's about the size of maybe like a cafeteria or refrigerator. And some of the specs I have written down here are kind of nuts. Like you can have about, I think, up to 170 different types of processors in it. And that's everything from like general purpose processors to special processors that just do Java or just do Linux on ZOS or just do crypto. And a main CPU or CPU on one of these things is like a 10-core, 5.2 gigahertz monster. I mean, that's just one. You can have hundreds of these on a thing. The low end of memory is like 320 gig and all the way up to 32 terabytes, I think, of DRAM on these things. And then, storage, it's sky's the limit as far as like SANs and everything else they're connected up to. So these are monstrous computers. Now I want to tell you a little bit about how to speak mainframer, because it is a very different culture and a very different type of lingo than what Windows and Linux admins are probably used to. So first off is mainframes don't speak ASCII. Their text encoding is an in-house IBM format called EBCDIC, which I can't remember what it's... Oh, Extended Binary Coded Decimal Interchange Code, if you're curious. So that's one thing is like, if you're ever like poking around a network with Wireshark, you might see funky stuff coming over, and you have to go tell Wireshark, oh, decode that as EBCDIC instead of ASCII, and then all of a sudden you'll see text. It don't make sense, which I did that before when I've had to pen test some mainframe applications that I was actually like, taking a look at and capturing the traffic from them. And then another one you'll hear a lot in mainframe parlance is LPARs, logical partitions. So what this is multiple OS instances all running simultaneously on one mainframe. Phil Young, who's like one of the big guys in like mainframe security research, he compares them kind of to VMs, but it's not really true because these things are running on the disk. It's like, you know how you can dual boot your computer to have like Windows and Linux on one hard drive? Well, imagine if you could just run them both simultaneously because you just had that much RAM, processing power, inputs, and everything. So mainframes will be running multiple operating systems simultaneously, and in lots of different combinations. They could have ZOS on several partitions. They could have other operating systems like ZVM or Linux on ZOS running on others, and all kinds of different configurations. A sysplex is a cluster of LPARs. They might all be on one mainframe, or they might be spread out over several mainframes connected over fiber optic, but that's another one you hear about sysplexes and parallel sysplexes. That's common mainframe parlance. A system programmer or a sysprog, that's the mainframe world equivalent of a sysadmin. So that's like the guy, who has, well, as you'll see, the equivalent of root access in mainframe world, and he's in charge of everything. IPL, initial programming load, that means just the phrase they use for booting the mainframe up. And then when it comes to storage, in mainframe world, storage kind of means two things. You can actually be referring to like disk, like DAS-D, which is direct access storage device. That's what you call a hard drive in mainframe world. And then there's also flash storage, and there's older stuff like tape. But they also use storage to refer to what we would call memory. So you might hear them refer to virtual storage, and you're talking about virtual memory. So that's one thing to keep in mind when you're talking to mainframers. Another big one is that they don't have files in the mainframe, they have data sets. And there's a couple different kinds. You have sequential data sets, and that's kind of like just a normal file. Like here I have an example of, I don't think you see my mouse. You have user1.data, that would be like a file. But then you also have partitioned data sets or PDSs, which are kind of the equivalent of folders. It's one file and it has several files inside of it. And they all have a naming scheme, kind of like a high-level qualifier at the front, then a dot, and then everything after. So the high-level qualifier is usually used to denote like who owns it. So if I'm user1 on the mainframe, all my files will start with user1 dot, and then I can put dots in between just kind of for like logical sorting. They don't really obey like file extension conventions or anything, but people kind of do it just to separate stuff out in the mainframe and just be able to visually look at it and make sense of it. Almost everything on the mainframe is run like a job, and that's all managed by JES, the job entry subsystem. You'll also hear mainframers call COS or the mainframe operating system, you'll hear it referred to it as MVS. and that's just an older name for the mainframe OS. The OS has changed names like 8 or 9 times. ZOS has been the longest. It's been the name of the OS for like the last decade or so, and I think it's going to stick around until they have some major hardware revamp. But yeah, you'll still hear MVS used a lot in mainframe world. So to interact with a mainframe, the traditional way is you use TN3270, which is also called the green screen. A TN3270 was originally like actually this. It was a model of IBM Terminal, but nowadays you can emulate it with programs on your Windows PC or your Mac or your Linux PC. It's actually a modified version of Telnet that speaks EBCDIC and it does color, and it's just what they use for their terminal sessions instead of Telnet or SSH. When you use TN3270 to access a mainframe, usually the first thing you're going to hit is called VTAM. Now, are there any mainframers in the room? I didn't even ask. Oh, yeah. Well, you just laughing at my jokes. I shouldn't have used. So don't kill me, because I know I'm like drastically simplifying this for the guys. But you can think of VTAM almost as kind of the portal to the mainframe, that when you start a TN3270 session, VTAM is usually the first thing you hit, and it usually has some kind of like splash screen. There'll be some cool, not ASCII art, but EBCDIC art, maybe with like a design or something. You'll see more of that later. And usually it'll tell you what applications are available, and you can pick whatever you want to get into from there. So you can think of VTAM kind of like the mainframe's portal. I know it's drastically oversimplified, but you know. Yeah. TSO is kind of the mainframe's shell. It's kind of like the command line interface for the mainframe. And then ISPF is the GUI, but it's a text menu-driven based system over TN3270. It's very like ncurses-y if you use like ncurses applications. Like Kismet on Linux has kind of an interface like that. It's text-based, but kind of like it lets you do mouse clicks and stuff like that, but it's all in text. And then every mainframe actually has Unix inside it. So you have USS, Unix subsystem, or it's still called OMVS. They're the MVS again, because it was originally released as Open Edition MVS back in the 80s or 90s. It was basically IBM's cheap way to get TCP/IP support into the mainframe. Like when Microsoft wanted TCP/IP support, they just ripped off like BSD's network stack. IBM's like, we're just going to shove a whole Unix inside this thing because there's just enough room for that. As you'll see, it's old and clunky. It's kind of like AIX. It's very AIX-y, but it's not AIX. It's not going to obey all the same conventions as that, but it has the same kind of flavor. So obviously, it's an IBM product. Now, mainframe culture is a lot different than like Windows and Linux admin culture. Mainframes are very customizable. Every install is going to have its own kind of culture. The mainframers are going to use IBM jargon. They're going to use their own jargon. They're going to have their own ways of doing everything. Mainframe's heavily customizable, so like every instance is going to be different. And a lot of these installs are very old. I mean, a lot of these people have been customers of the mainframe since the 60s or 70s, and they've been buying every continuous generation of hardware. And a lot of those mainframers might have been around since the 60s or 70s, and they've been using this platform for a very long time. So mainframes kind of want to be centralized and kind of want to be distributed at the same time, because they buy this like one enormous box with all these processors and all this RAM, but then it's carved up. It can be carved up into LPARs. Inside one of those LPARs could be running a hypervisor that's running hundreds of Linux VMs. Like, it's kind of weird how it's like it wants to be centralized and decentralized at the same time. And then another thing about the mainframe is it's so old that it predates really the concept of user security. Security, when the mainframe platform started out, was you just locked the door to like wherever you submitted the job cards or you got to the green screen physical terminal at. So ZOS has some like rudimentary security built in, but it's had external products that have like filled in the gaps in the meantime. So the big three are RACF, ACF2, and Top Secret. I'm just going to cover RACF. It's, I think, by far the most popular. It's actually the IBM official external security manager product, and it's the one you're going to see the most often out in the wild. So RACF has a database that holds everything concerning security. It'll store all the permissions for all the files. It'll store password hashes. It'll store crypto keys, everything. When you're on a mainframe, like in an ISPF or TSO session, you can run the rvariant command, and it'll tell you where that database is located, in case you want to steal it later, which, a lot of times you can. There's no real concept of root or admin in the Unix world. The closest thing you have is you have special permissions on your account, which special permissions means you can just give yourself access to anything. So like you say, if you have special, you could say, okay, I want to have access. You could issue commands to say, okay, give me access to this user's files, and it's done. But it's not like a one and done root. Historically, passwords very weak, and hash functions have really sucked. They've gotten better in recent years, but a lot of mainframers haven't updated because they very much have a philosophy, like a lot of programmers and admins, of if it isn't broke, don't fix it. We've gotten by just fine on 8-character passwords for the last 40 years. Why are we updating now? so something to keep in mind. Now on the platform, your big programming languages are going to be assembler. A lot of stuff is still written in C assembly. COBOL obviously is a big one you hear about in the mainframe world. PL1 is still fairly big. Fortran seems to have dropped off. I see less and less mentions of it in IBM literature. I don't know what's going on there. And then via USS, the Unix System Services, you also get access to Java, C, and C++, and more modern stuff. And Java is very popular on the platform. Now, the scripting languages you have on a mainframe, the biggest one is JCL, which is Job Control Language. That's actually the language you use to set up a batch job and submit it to be processed. And we'll see some of it later. There's another format called CList, which is kind of like a .bat file in Windows or a bash script, where it's just a list of TSO commands. It's not that common anymore because it sucks. TSO is very limited, as we'll see a little later. Rex is much more popular. Rex is a scripting language that's more comparable to something like Perl or Python. It's a lot more powerful, a lot easier to read, a lot easier to use, and that's like by far the most popular scripting language for sysprogs to do their work in. And there again, with USS, you get access to a lot of stuff like bash scripts, Perl, TCL, things like that. And then, in particular, there's a company called Rocket Software that's ported Python and a lot of other stuff over to USS that a lot of it's free. You can download it from their FTP site and install it. Now, briefly, I'll touch on CICS and IMS. So CICS stands for Customer Information Control System, and in IMS, I don't remember the hell IMS stands for.
Information management.
There you go, Information Management System. These are what are called transaction managers. CICS seems to be way more popular than IMS. I see a lot more CICS apps than I do IMS. What you can think of it is it's like a purpose-built application on the mainframe so that you don't have to teach the normies how to use TSO and ISPF. If you go into, I was in a hardware store recently, and I highly suspect that when I asked them where something was, they pulled up this black screen and were typing stuff into these like text form fields. I highly suspect that was probably a CICS application. It was probably a central mainframe that they used for all their inventory. You also see them with like web front ends or like desktop application front ends. It's just like a purpose-built app so that people can more easily learn how to do mainframe stuff. But really, they run over TN3270. Like I said, there might be a web or a desktop app front end, but on the backside, it's speaking TN3270 to communicate to the mainframe. A lot of security is client-side. It's relying on actual quirks of the TN3270 protocol to like hide fields or say that you can edit this but not that. And much like most client-side security, it sucks. There's lots of ways to hack it, but it's way too big of a subject for me to cover. I would direct you to Dominic White, aka Singe. He presented on Recon several years ago about CICS security. And then Ayub Asal has done some great work on the subject. If you want to learn how about CICS hacking, it's pretty cool. But now, what I want to show you is a couple of demos to see what the mainframe looks like, which I took no chances because the network here doesn't let you go to anything except 80.443 unless you're on a VPN. Sorry, let me find my documents. I'll play some videos I recorded of using the mainframe. Okay. All right, first off, here's a little demo of TSO. So, sorry, again, I apologize for the projector here is kind of funky looking. Hopefully you can read this. Let's see. So this is actually a program. This is called X3270, which is a X11-based terminal application. You can use on Linux and Mac, stuff like that. There's other apps for interacting with it. There's even console apps like you can do from your terminal window. So I'm going to connect to a mainframe, and here you can see some of that nice Epsidic art. Hopefully you can make that out. Can we turn the lights off or something? Maybe it might pop a little better. Yeah, it's really wild. There we go. Okay. Sorry to make the room so dark, but hopefully it'll pop a little more.
So I'm actually connecting to an IBM mainframe called, it's part of a program they do called Master of the Mainframe. It's their attempt to desperately get kids interested in mainframes because all the old mainframers keep dying off and they need to replace them. It's their way to save the endangered species of mainframers. Wow. So I've connected, this is VTAM. So I've hit VTAM right now. It's kind of the portal. And if you ever are wondering what the hell, am I at VTAM or not, you can enter this command, IBM test, and hit enter. And it'll always enter this little thing. It says IBM Echo, and then it does A through Z and the numbers. It's just a debug, test program, obviously. So I'm on VTAM, and then usually the message will tell you what options you have. And this one I can do log on, and then it's going to ask me for my username, which in that format is Z30858. And then here's the TSOE login screen. I'll put in password. And then I'll get some messages. It takes a minute to load up. It's on Central Time. We'll see some more Epsidic art here in a minute. Come on. Go slow that bit. Really slow that bit. There we go. There's an Epsidic art. It's a little map of the world, and it's hard to make out with the little Master of the Mainframe logo in the center. And so it'll tell me some messages. This is also where sysprogs can kind of send mail, wall messages out to users to tell them things. And so I get in. There we go. So that's the ISPF menu, but we're going to exit out of that real quick, and we're going to TSO. So here I am at the ready prompt, just like a freaking old Commodore 64. That's your prompt at TSO. It just says ready, and then you enter commands. So here I'm going to do list user. And then that's just like running ID on yourself. So it's just going to print out some information. I see my username. It shows some esoteric information about my permissions and stuff like that. I can hit the clear screen button with my little application over here to clear the screen out. There's no clear command like in Linux. I can also use that same command and abbreviate it. So instead of list user, I do LU. And then I can run it, and then I'm going to add some options to it to get some more info. So I asked it to show me my OMVS info, so I can see where my Unix home directory is and stuff like that. Now I'm going to run profile, which profile is kind of like your bash RC or bash profile. It just kind of has some information about your session. One of the big things in there is that your profile usually defined that whenever you're interacting with files, I should just automatically append my username and dot, my high-level qualifier to everything, because it kind of keeps me in my little zone. To keep me from messing with the higher level files. Now here's a familiar command. I can actually run ping, and it'll actually do that. I pinged Google's DNS server, so you can run a ping command from there. And there's several other TCP and Unix commands that have been ported over, like netstat. Oh, so here's the thing. When I reach the end of a screen in TN3270, I'll get 3 little asterisks. And then from there, I just have to hit enter again, and it'll clear the screen and start me at the top. There again, it's very old. It's very much a remnant of using an old physical terminal. But I can run netstat home, and I can find my IP address. It's kind of the equivalent of running ifconfig on a mainframe. If I hit enter, it clears it out and rewrites the rest of that command. So see my loopback interfaces, whatever. So next up, I'm going to do list cat, and that's going to show all the files here that. The ZOS file system is very flat. It's not I think it's actually called hierarchical file system, but it's not very hierarchical. It doesn't work the way Windows and Linux file systems work. Everything's kind of flat, and you use high-level qualifiers to kind of tell where things are supposed to be or who they belong to. But like I said, it's not like things are nested inside of folders, other than those partitioned data sets is about the only kind of thing. So if I do list cat, the default according to my profile is it's just going to list the stuff that belongs to me. So all the stuff with my high-level qualifier. So here I've got a bunch of scripts and files and stuff in my home directory. And now I'm going to do list ds on that JCL file. So when I just type JCL, because my profile knows automatically to start it with z30858.jcl. So I hit JCL, but it knows it goes to this file in my home directory. And so I do list ds to just see some info about it. It'll show me how big it is, how many memory blocks it takes up, yada yada. There again, I'm at the bottom of the screen, so I'll hit enter and clear it out. And then I can do list JCL to members to give it some arguments. So I can see that it's a partitioned data set, and it has members in it. So remember, PDSs are kind of like folders. So here's all the other little files that are inside it. I can do listcat again, show that, I clear the screen out. Now I can delete files, so I can do del, and I can delete this unitcommand.jcl thing. Run that, it's gone. If I listcat again, you can see it was here. I list it again, it's no longer there, so I've deleted it. A lot like using DOS. I can rename files, so I'm going to take this test.jcl and rename it to the old file I deleted. There it goes. I can do listc and see that it's been renamed. Now, there's no real equivalent of cat in TCO world, or type if you're using like old like command.exe. But what you can do is you can edit a file, and you use the edit command to actually take that file. So I've opened it up, and now I'm in the edit interface. So now I have to tell it some commands. So here I say edit, I'm going to edit that. And also I showed you here with single quotes, I can give like the absolute path of a file or a data set. So I'm using edit, and you can see I'm opening that unitcommand.jcl data set that I just renamed. So I enter what type it is, and I do cntl, that's telling it that it's a JCL, it's a job control language file. So it's opened up, I can do list, and that's kind of like running cat on it. So now I'm going to cat it out. That's what JCL looks like. We'll see a better look of it in the ISPF section when it's like nice and color-coded. I can do end no save, and then I'll quit out of the editor and bring me back to the regular TCO prompt. That's kind of how you list out file contents. It's very clunky. Here I'm going to look at another file, and this one is a text file. It's actually a rec script. So I'm going to look at it. It's going to ask me what this type of file is. I'm going to tell it it's text. And there again, I'm going to do list after I clear the screen. I'll do list again. And then you can see this is a rec script, which hopefully looks a lot more familiar to a Windows or Linux user. You can see it's a scripting language. It's a lot more readable than like JCL. I'm at the end of the data. Okay, I do end no save to just close it without doing anything, and I'm done with that. And now I can execute that program with the exec command. I can run rec script and various other things. So I'm going to run that, and what this file just does is it prints out all of the Linux user, or sorry, the USS, the Unix System Services users on this box. Which, ooh, there's a lot of them. I'm on this big old mainframe. There's hundreds of users. Now, the equivalent of like hitting Control-C to like kill whatever you're in is the PA1 command, which I have it on the little virtual keyboard here. It's also, depending on what kind of TN3270 emulator you're using, it'll be mapped to keys. It's usually like, I can't remember what it is now.
Escape key.
Yeah, it might be the escape key. It depends on the software you're using. Or it might be mapped to one of the function keys. So if I'm in a program and I want to get the hell out, I just hit that key. And then it's going to say, are you sure? And it says enter high to end. And I enter high, and so I get out of it. So now I'm going to allocate a data set. And this is kind of like running touch or something like, or T or something like that to make a file. So I'm going to say allocate a data set called test.data and make it like test.jcl. That's about the easiest way to make a file, because allocating files is really freaking clunky and hard in mainframe world. Because you have to tell it like how big it's going to, you think it's going to be. It's like making freaking strings in C. It's terrible. So anyway, I just did that. I made it like that. Actually, I screwed up the first command. I had to give the wrong name. So there, I made that test.data file. Run list ds on it to show like how big it is and some info about it. And now I'm going to log off. And that's the end of that. Now I'll show you ISPF because no one really uses TSO. I mean, most sysprocs don't get into it because it's just really old and archaic. TSO has a lot. ISPF has a lot more features and is a lot more complete. So that's what most admins spend their time in, or sysprocs. So I'm gonna connect to the mainframe again. Same one. It's just the master of the mainframe. I'll log in. Put my wonderful 8-character password, it only allows 3 types of special characters. So this is the ISPF main menu. And you see it's very, very easy to use, very like number menu driven. You just enter the number of what you want, or they have a couple other functions here for like little code words to jump to stuff. Like I can do U to just jump into a Unix shell. I can do SD to go to SDSF, which is like the main like job control program to see what jobs are running and view their output. We'll see it in a minute. So first off, I'm going to run TSO. I can run that command from here, and then follow it up with a TSO command, and it'll run, oh, you can't even see it. It'll run it like right down the bottom of the screen. It'll start printing out a TSO command. So I just did list cat to show the data sets that belong to my user. There it goes. Okay, and then here I did 3. Let me just back up a little bit. A little fast there. Okay. All right, so I'm going to do 3, which is I'm going to go to the utilities menu, as you can see, because 3 is utilities. And then I'm going to go to 4, which is DS list, which is a program for listing out files and stuff like that. So you can see here the DS name level is just automatically set to my user's files. And then I can get a listing. It's just like running listcat. But ISPF has a built-in editor. So I'm going to go over here to my JCL program, enter some gobbledygook, and then here I have this nice little visual editor, kind of VI-like, to edit it in. So here's what the JCL job looks like. It starts off with the slashes with some information that kind of tells like what priority the job's going to be, how it should be sorted, how important it is, what program it's going to use to execute, where it should take its input, where it should write its output. It's all very esoteric and very fussy. If you screw one freaking space up in it, it'll botch the whole job. So it's very. I don't know. I've even heard that most of these sysprocs don't write JCL from scratch. They just keep old JCL jobs and just modify them accordingly because it's so easy to screw up. And this is just one that's just going to run some TSO commands. You can see it's going to run LU for my user and list my user's info. It's going to run netstat home to see our IP address, and then it's going to run list C in order to list out my home data sets. So if you see here, I can actually go here and type in D in that line numbering and hit enter, and it'll delete a line. Or I can type, you couldn't quite see it, but I type 8, I can add a line below it, so you can add lines. You can also put numbers in and add 10 lines below something. It's very configurable. So then I'm going to add that back in, and then I'm just going to do save to save the file, and then I'm going to do submit. I'm going to submit the JCL. Now I'm going to hit the PF3, which usually maps to the F3 function key when you're using JCL. It's just basically the back key. So I'm going to use it. I'm going to go back to the main menu. And here I'm going to go into SDSF. SDSF is where you see all the Mainframe's jobs. So I'm going to dig into these menus. I'm going to go find my job that ran. So right there it is. A question mark to view it. I'm going to go to the system printout. And I'm going to take a look, and I'm going to see it. And you can see here, it ran the LU command. You go down a little further, it ran netstat home, and then there ran list C. So I just ran all my jobs and successfully completed. And I use S4 to quit out of that. And also, you don't have to do 3 utilities and then 4 things. You can do 3.4, and it'll tell it to go to the utilities menu and go to the 4th item. So it's a little shortcut. So we jump right to that data list thing. We're going to list files. And now I'm going to look at another JCL job. And this one, instead of TSO commands, it's going to do Unix commands. So as you see here, it looks a little different. But the important part is the parameters it takes. It's going to tell the BPX batch program, which is just a program that runs Unix jobs, and tell it to run a shell and run the ID command and then netstat-h, which will be, netstat home, show us our IP address. So I'm going to submit that job. And then here's another little time saver. I can do semicolon and then do equal sign, which is kind of like saying go back to the top level and do this. And so I'm going to do the SD so that I can just jump back to the main menu, go to the SDSF program, then feed it more commands to say, okay, then when you're inside SDS, type the ST command to go to the list of jobs. So much like with Unix and Windows, there's lots of command line time saving kind of stuff you can do. And there's my Unix job. It completed. It showed the ID for my user, my UID and my GID, and then printed out that stat information. And then exit out of that. And now I'll show you guys what Unix looks like. I'm going to run TSO, and I'm going to run the OMVS command. So that will take me to which OMVS is what a lot of mainframers call Unix inside there. So it's the old name, the Open Edition MVS. And so here I get this Unix shell where I can submit commands. So I submitted ID, I can see my UID and GID. I can run uname-a, and I can see the information. It still says OS 390, which was the last name that ZOS had. I don't know why it hasn't been updated, because this is a brand new mainframe. I'm not sure what's going on. It's very slow to update those things. And I can do all sorts of normal Unixy stuff, like I can list out the contents of my home directory. You see I've got some files in there. I can delete stuff, like I'm going to delete that Rex file. Now here's one that's interesting. I'm going to copy a file from the MVS file system over to the Unix file system. So if you look here, I did copy, and then in double quotes, I did // and then in single quotes, I did the full path name, I guess you'd call it, of my data set. So z30858.hello.rex. That's a file data set you saw earlier. It was that Rex script I had that was like sitting in one of the Rex scripts that was sitting in my, is because you call my home directory on the MVS side. It's telling it I'm going to copy that from the MVS side. I want to copy it over to Unix, and I'm going to rename it hello.rex in lowercase. So I do that, and now I can cat it out. And it gives a second, and it'll print it out. And there's my little Rex script. I can also run it as an executable. I can do chmod +x and make it an executable file. And IBM has, a Unix-based Rex interpreter that can run it. So I can do just hello Rex, and it just prints hello world. Now, also on the Unix side, I can also run TSO commands. So there's a very common, I don't think it's actually built-in, but it's a very common, every install has it. There's actually a Rex script called TSO-CMD that just passes commands to the MVS side, runs them, and brings you the output back. So here I'm going to do TSO command and run list C. And it'll take a minute, and there it ran list C and showed the contents of all my data sets that I own over on the MVS side. And then I can exit out. And the job's over, and it'll kick me back to ISPF. Eventually. And there you go. And then I can do X and exit out, and it'll ask me, because since I generated files through my jobs I submitted, it's like, hey, what do you want to do with them? And I'm like, just throw them away. I don't give a shit. So I'll do action 2 to delete data sets. So they're deleted. I'm out. I log off, and I'm done. So let me find my mouse. Where are you? There you are. Okay. So back to our presentation. All right. So before we get into hacking mainframes, I want to talk a little bit about overcoming organizational obstacles to mainframe pen testing, because that's probably the biggest problem, is getting to test the mainframes that your organization has. So I'll start off by talking about my first encounter with a mainframer. So I used to work for a very large company here in Louisville, and we had mainframes, and at the time we were looking at privileged identity management solutions. And so we were looking like, okay, well, we want to manage our root accounts on Linux. We want to manage our domain admins. Let's talk to the mainframe folks. We'll see what their equivalent is, and we'll see if we can find a product that manages their stuff. So me and another guy who was also on the security team, he was a former IBMer, so he spoke their language a little more. He was on the call with me, and we called these three guys who were over in our data center, way out. So I never knew exactly who it was. There were 3 guys on the call, and I don't remember whose voice was whose name, but a couple minutes into this conversation, one of these guys just starts going off on us about how you security people are always trying to get in our business, and if I can't get to my, if I can't get into my special accounts and be able to mess with jobs that are acting up, and if that mainframe goes down and I can't get in, the company's going to lose millions of dollars every second from lost transactions. He ranted at me for 10 straight minutes. And I'm putting the phone on mute and I'm cracking up, and I'm chatting to my colleague that wow, it's I thought Unix graders were surly. They didn't got shit on mainframe sysprops. Eventually we calmed it down. We're look, this is just exploratory, dude. Don't bite my damn head off. But that's kind of what you encounter. Some of them can be very set in their ways, and they don't like you coming along and messing with their shit. It's understandable. But the big problem with mainframes is the mindset. Because a mainframe is simultaneously this, Fort Knox, if anybody doesn't know what that is, the bulletin repository. Mainframe is simultaneously this, And it's also this. It's a hemophiliac baby in the middle of a room full of Domino's and Fabergé eggs in China. It's like, oh, the mainframe it's got the most high-end, up-to-date security from IBM. It's completely impenetrable. It's never been hacked. But also, it's my sweet little precious baby, and if you so much as poke it, it's going to fall over, and we're going to lose $1 billion in lost transactions. It's like, pick one. You can't really have it both ways. It's either one or the other. And really, it's actually much more this than it is that. So your first obstacle is really the mainframers themselves. Mainframe knowledge is much more guarded and it's much less accessible because there's a huge barrier to entry to owning a mainframe and being a mainframer. You know, I mean, these are on the low end, it's millions of dollars to own one of these things. It's not as easy to get into and learn as like Linux and Windows are. Mainframers are very much steeped in their own culture and their own jargon. Like I mentioned, these are very, very old computing cultures that go all the way back to the 60s and 50s. They skew a little older, but IBM's trying to fix that. Like I mentioned, the Master of the Mainframe program is something they promote to colleges to try to like save the endangered mainframer species. They very often have a, if it's not broke, don't fix it mentality. If jobs are running fine, they don't want to stop stuff and risk updates that might work through the process. They can be incredibly surly, as I have encountered directly. The biggest thing is just assure them that you respect their platform. You respect how important to the business it is, and that you're not there to like dunk on them or make them look crap. You're there to help them improve their processes and improve their security. That's the biggest thing is if you can get them on your side, things will go a lot smoother. Obstacle 2 is the fear. Like I mentioned, everybody's afraid that if you just so much as breathe on the mainframe, it's gonna, fall over and crash. It's perhaps the biggest obstacle from mainframers and management, but especially management. Because mainframers know everything about the platform, and upper management knows nothing. All they know about the mainframe is what the mainframers tell them, and all the mainframers tell them is doom and gloom if you touch it. So that's the biggest obstacle to overcome is, like, these guys, just filling management's head with, oh, we can't touch the mainframe, we can't touch the mainframe. No, it's too valuable, can't touch it. But the truth is, it's just a fucking computer. It's just like any other computer, okay? Yeah. It takes effort to brick a mainframe because for a computer, it's a damn ungodly, strong, and reliable computer. I mean, these things are built for availability. It takes a lot to DOS a mainframe. Trust me. And also color bullshit because, like any environment, if it's that precious and valuable, they've got QA. They've got test environments that you can run in. So if they want to let you do prod, fine. They've got QA LPARs or whole QA sysplexes that you can test it. Another one is hubris, especially if you deal with IBM itself. Mainframers can be very secure if they're configured properly, but they do get hacked. It has happened. Just because it's never happened at your org doesn't mean it won't. The biggest, most high-profile one was a guy named Gottfried Svartholm. He goes by the handle Anaconda. He was one of the founders of the Pirate Bay, the big torrent and movie pirating site. He was in hot water with the Swedish government, was hiding out in Thailand, and he decided he was just going to hack a bunch of Scandinavian countries to get back at them. So he hacked Logico, which is a big Swedish company. He also hacked a Danish bank. There was a third company in Norway that had its mainframes hacked that I think they're still trying to prove he did it, but it's pretty much thought he did, but they haven't definitively linked him to it. He was able to hack into them with some pretty old school tricks that probably wouldn't work back to 2012. He was doing old school CGI hacks that wouldn't have worked in 2012 against most Windows and Linux installs. But mainframe still had these problems because the mainframe wasn't getting any scrutiny. And IBM is all about security via obscurity. They do not publish CVEs. They don't publish security advisories except through their private mailing lists. And the only CVE they actually have is a result of the Logica breach because basically the EU made them issue a CVE. And the CVE was even they tried to claim it was a problem with Tivoli when the actual problem was with ZOS itself. So they were even dodgy when they were actually forced to publish a CVE. And then also, even if you do drink the IBM Kool-Aid, then what's the harm in letting the pen testers have a crack at it? If you believe that what IBM says, that it's so secure that it can't be hacked, then what's the harm in letting us try? So now for what you've all been waiting for is, how do I hack mainframes? So I'll walk you through a little scenario, and then we'll have another video demonstrating a little attack path. First off, go ahead and Nmap it. It's fine. It'll live. It won't fall over. It won't die. I think there was a problem with the time to live on like SYN packets back in the day on like IBM or the ZOS TCP stack. Or maybe it might have been AS400s that had this problem. But AS400s or ZOS had a problem where like the time to live value on like Synapse was like ungodly long, so like you could actually like SYN flood it just by port scanning it. But that's like been fixed for like 30 years now, so like you don't have to worry about it. It'll be fine if you Nmap it. Because it does have lots of stuff that lives on non-standard ports. So be sure you Nmap everything. Use -B-, get all 2 to the 32nd power ports covered. And if you have access to it, if you're kind of doing like a red teaming scenario or you're just looking to do some OSINT, take a look at their intranet knowledge sources. Because usually if you're doing a mainframe pen test, you're probably doing an internal pen test. Because most companies aren't putting these things out on the internet. Some still are, but you're probably in an internal environment, so you might be able to find their Confluence or their SharePoint. Start searching for mainframe terms. Search for terms like KIPS, LPAR, TSOID, which I know there's some of you that work at a company where your username is called a TSOID. That's why. It's because all your shit was built for mainframes. I also worked at another company where our username was an A number. It was A and then a 6-digit number. And it was also because of mainframes, because of old RACF like username constraints. So anyway, search the internal internet for terms. Like, look for things like attachmate, kicks, the mainframe terminology. And maybe you can dig up some info and find out like about like maybe what their naming scheme is for their mainframes, what their username scheme is like for them, things like that. If you've actually compromised your workstation, like maybe in a red team scenario, take a look and see if the mainframer, if you've compromised a mainframer's laptop or somebody who uses the mainframe, you might be able to find config files or scripts or host-on-demand jars or documents or like their Rumba config files, which Rumba is a big commercial TN3270 emulator. It's very popular. You might be able to find passwords stored in there. You might be able to find, mainframe application names, things like that. So the things you do want to look for is you want to look for the LPAR's names and IPs. Excuse me. You want to look for Kix region names if you're going after Kix applications. Username and passwords. And of course, try to find some creds. So there's an example output from Nmap. I know that's very hard to read. But some common ports you might see is FTP and SSH. Those are pointing to the Unix side. Port 23 will often have 3270, or there might be other like iterations of 23, like port 1023, port 2023, 4023 might be hosting different TN3270 portals on them. 5042 is where like DB2 lives. That's very common to find DB2 on a mainframe. There's lots of other stuff. So how do I get these creds? Because hacking a mainframe is pretty pointless without some kind of account. There aren't a lot of ways to go from like zero access to getting in. Like there's not a lot of, it's like Windows and Linux anymore, It's hard to find those kind of hacks. So generally you want to try to find some kind of account, even if it's low priv. So one thing you could do is if you're on an internal network is you can just sniff, because lots of TN3270 installs, they can use SSL, but like less than half do, I think. So that stuff's just flying over the ether, just like Telnet. It's unencrypted, so if you can get man in the middle or get somewhere where you can sniff that traffic, you can listen in for it and just pull creds out of the air. Like I mentioned before, like you can steal them out of config files or for people's FTP scripts or KeyPass documents, things like that. You could phish them, social engineering. Phil Young, the mainframe hacking researcher I mentioned before, has a tool called SET N3270, which is like social engineering toolkit, where you can actually like man in the middle of someone and put up a fake TN3270 like VTAM login prompt and then phish them for credentials that way. Reuse is always a big thing because like I've worked at companies where we had crap password requirements because it was lowest common denominator because they were syncing passwords between AD and the mainframe. So your password had like stupid requirements, like it couldn't be longer than 8 characters. It could only have like exclamation point, ampersand, and pound as the special symbol. Special characters are the only ones allowed. Things like that. So check that. If they're AD pass, if you fish somebody's Windows creds and they look like they might fit the RACF format, try them out. They might be syncing them. You can brute them, but be very cautious. Because by default, there's no lockout on mainframes, but pretty much everyone has set it. And it's usually pretty aggressive. It's like 3 bad tries or 5 bad tries, and you're locked out. And it's not like Windows where you can spray. Like you can try like one every couple hours, and the lockout threshold will reset after a while. It's like if you do 3 bad times, it's done. You're locked. You have to go get a sysprog to let you back in. So if you're going to spray, you have to be very, very careful. You can only do it like once or twice.
Can you do that on an admin account or
any
account that
TN3270?
because like an admin account wouldn't
said.
No, all of them. So, if it's desperate enough, you have to like go to like the physical terminal on the thing and go to like the IBM user service account and like unlock it if it's that bad, I guess. And also that does apply to like SSH and FTP. There's no loophole around that. 3 bad attempts to log into SSH on the Unix side, it talks to RACF, it locks you out. So I even tried that to see if maybe I could get around it. Or even if you're logged in, trying to do SU to switch to a different user, same story. 3 bad attempts, locked out. Or, whatever their policy's set to. So brute with caution. So once you have targets and you've run detailed scans, there's some enumeration options. Phil Young has produced tons of Nmap scripts for things like brute forcing all the VTM application IDs, figuring out logical units, which there's some trickery there. You can actually use logical units to do like kind of like a session hijacking thing. I'm not really going to go into that, but that's one thing you can do is look for those. Kicks transaction IDs, TSO user IDs. TSO is nice enough to tell you if a username is valid or not. I guess maybe that's where Microsoft got the idea of, because if you hack Windows stuff, you know that like Exchange and Office 365 are really nice in telling you that a username's valid. So TSO will tell you if a username isn't good, so it's very easy to enumerate usernames. You can do that with scripts. And as long as you just do the username but don't enter a password, you're fine. You can just do that forever. You won't lock anybody out. It only locks someone out if you actually attempt to send a password after you've entered the username. So if you've got creds by this point, just try logging in. Now there's one caveat. Some users might only have access to TSO, or they might only have access to Unix, but not both. And we'll see that scenario in the video. TSO is also nice enough to let you know that your user ID is already logged in. So if you enter it and it tells like, oh, you can't come in, somebody's already logged in as you, then you know they're on there. But by the same token, if you're logged in with their account and they try to log in, they can see that somebody else, that you're occupying their space. So opposite consideration right there. So it might affect like when you operate. You might have to do stuff at night, so you're not stepping on the toes of users. And then SSH or FTP allows multiple logins as the same user, so it's a little stealthier that way. So if they do have access to both, just do SSH or FTP. They won't immediately figure out that you're logged on if they come along later and try to get in. So FTP is interesting on ZOS because you can actually run JCL and SQL jobs from FTP by just uploading a file, which, yeah, it's RCE as a service. It's very, very handy of them. So we'll use that later in the video to actually get a foothold on the server. And then there's some other options you have once you have that. They've written Metasploit modules in order to get shells through this. There's lots of tools out there from Phil Young, Chad Ricken's and some other big researchers in this area. So once you get in, NJE is network job entry. So this is a way for people to submit jobs to different LPARs or to different sysplexes. It's kind of like, I can take my user ID and I can go submit a job somewhere else. So if this port's open, by default, all you have to do is you have to know like the node name and then like a valid username on the box, and you can just submit jobs. And also, they're usually enumerable because the NJE protocol will tell you if a node name is valid or not. You can require it to set a password, but it's a static password for everybody, and it's very easy to root. It has no lockout threshold. And then also, if you break into one box, you can go find that password in a config file in plain text, and then just go use it to like log into every node that it's connected to. So it makes lateral movement very easy if they're using NJE. Kix is another one where you usually need some kind of creds to log into Kix. And there's lots of options if they have these very bad transactions enabled that will let you get shells and do all kinds of stuff, which, again, I can't really go into because it's a topic to itself. So, okay. All right, so web servers. Web servers are always usually running on the Unix side, so just treat them like any web server. Try Nicto, try directory brute forcing, things like that. WebSphere and Tomcat are common, and the same kind of tricks apply. If you can get into Tomcat, you can upload a WAR file and give yourself like a Java shell. Older ones have crappy like CGI apps with command injection, and that's actually how Anaconda was able to hack Logica. DB2 is also on the mainframe. I think this one needs a lot more attention because I haven't really found much stuff about hacking DB2 and like messing with like stored procedures and stuff. I would love to do more mainframe research, but my current company can't afford one because they're just too damn expensive. But if your company does and you want to get into this space, that's a great place to look and do some research is look at DB2. And there's other old insecure stuff you may find. You might find network file shares. You might find our login still working on some places. All that stuff. So once you're in, you might be able to stop right there. You might not need to get special because, like anything, just check and see what you have access to. If you're on a more realistic mission that you're trying to break into the mainframe and grab sensitive data, the user you've compromised might already have it. They might not have special permissions, which is basically like RACDEF's version of like having root. But you might not need it. They might already have access to the stuff you want. And like any pen test, once you're in, enumerate some more. There's some great scripts. Enum is a great script to show you like all kinds of jobs you have access to, or different types of files that may be exploitable for you to privesc. Excuse me. Okay, so a little pro tip for navigating around the mainframe is for exfilling, FTP works real well. Oh, sorry, secure copy works well. And then there's that IND file, which is actually a TM3270. It's a built-in file transfer protocol. That works well. SFTP does not. I've had terrible luck with SFTP screwing up trying to translate EBCDIC to ASCII and back and forth. But for some reason, SCP works. I really don't know why. There we go. Okay. But obviously, if you've gotten this far, you want to get special, right? You want to own them. You want to get the equivalent of like domain admin in the mainframe world. So the MVS side has some unique privesc options that are very unlike what you'll find anywhere else. So one thing you can do is you can check off the bat to see if they have the default super user enabled, which is IBM user, usually has a password of sys1. But you're probably not going to find that. He's almost always disabled. There are JCL surrogate profiles, which surrogate profiles let you submit jobs as another user. So maybe, the sysproc's tired of being bugged by some user to submit a job for him with these special permissions. So he's like, fine, I'll do a surrogate, so you can always submit this job as me. Well, obviously, if that person you can submit as, has elevated permissions, you can exploit that to, change your own permissions, give yourself a shell as that person, etc. There's also what they call supervisor calls, and certain badly written ones are called magic supervisor calls. What they are is they're a type of customized system call in the mainframe like guts that lets you execute code in supervisor state, which is basically like ring 0. So ZOS, like I said, very heavily customizable, even lets you customize these deep level system calls. And so it's not uncommon to still find places where they have these really bad ones that are just let you do anything. I get the impression that a lot of places have rooted those out and gotten rid of them and have much better security, but there's scripts and stuff to be able to look for these magic SVCs and find them. And then there's also APF authorized libraries. So APF stands for Authorized Program Facility, and these APF libraries, they're partitioned data sets that contain binaries that can run code in supervisor state. It's kind of like setuid in Linux world, where anybody can run it and it'll run kind of like surrogate, on behalf of the, at an elevated level. It'll run as root. The problem is that a lot of times developers will put a lot of stuff in these PDS, these partitioned data sets, to distribute them, and maybe only one data set in that PDS really needs APF authorization to be able to do this elevated task. But you can't set it at a granular level like that. You have to blast the whole PDS and make it APF authorized. So they'll just do that and give you the whole thing, and then maybe one of the files in there, you have alter access to it and be able to customize it, and then you can just blast it and give yourself admin. Now, privilege escalation on Unix is a little more complicated, because the usual tricks for root all work here. All the stuff you've done before to get root and Linux and Unix stuff works. Abusing set UIDs, if they have bad sudo permissions, things like that. But the problem is that owning USS does not mean you own MVS. If you're root on the Unix side, you're you're the king there, but you still don't have permissions on the MVS side. You're still screwed on that one. RACDEF still controls all the user accounts even when you're root. So yeah, you can pop root on USS, but that doesn't give you special permissions or anything over on the MVS side. You'll have to find other ways to get it, which I'll show you one. There are other ways around that. The one I won't show you is there are actually also APF authorized binaries in Unix. Chad Rickensrud, another big mainframe researcher, is doing some work on that. I've been bugging him when he's going to publish his stuff, because the APF stuff is very well documented on the MVS side, but not on the Unix side. So he has some tricks for how to abuse APF binaries on Unix in order to give yourself total ownage on the mainframe. But watch that space; it's penned. It'll be coming someday soon. But what I'm going to show you actually is backdooring the sysprox account with SSH keys. So a little bit about lateral movement. Once you get on and say you've got sufficient permissions, just like on Windows or on Linux, you can just dump the password database and start cracking. So you remember the rvary command I talked about. That'll tell you where the RIF database is, what the name of that data set is. And then you can, if you've got the right permissions, if you've elevated, or sometimes they have bad permissions set on from the beginning, you can exfil it and then go about cracking passwords, do all that kinds of nasty stuff. John the Ripper understands RACF, so it's trivial to crack those passwords. Also helps if it's an older, if it's one of those places that still only has like 8-character passwords. Okay. Also, like I mentioned before, you can also use NJE because that password's shared between all these users. So if you get on one box and you're using NJE, you can go to that config file. It's usually like sys1.parmlib. It's a PDS and it's a jes2parm dataset. We'll have that password in clear text. So you can use that and then use NJE to just go hop around in it, the sysplex. And now I'm going to show you a little hacking demo here, showing how you can go from very few permissions to owning the mainframe. Okay, so I got two windows open. I've got a Unix window, and I've got a TN3270 window. Sorry, let me full screen. There we go. Okay, so this is a different mainframe than the massive mainframe one. I'm going to connect to it. So I'm going to try to log on as Eve. I try to enter my password. It says my password's okay, but it kicks me out. It says default account numbers could not be obtained. So basically what it is I don't have TSO permissions. I'm not allowed to log into TSO. But it's a valid account. Okay, whatever. I'll disconnect. I'll go try Unix. So I try SSH as Eve. So there it goes. It's going to ask me for my password in a minute. Okay, type my password in. Oh, permission denied. Denied, denied, denied. Okay. Looks like Eve doesn't have USS permissions either. What about FTP, though? Hey, okay, Eve. Put the password in. Hey, Eve can log into FTP. All right. So what's over here? So here I'm on the MVS side of FTP. Or no, sorry. Yeah, sorry, that is the MVS side. Okay. So I start off over on the MVS side, so I can see my MVS data sets. But I can do CD to my home directory, so I can do /u/Eve. So that's Eve's home directory on Unix. And so now I can list that. I don't have anything in there right now. But now I'm over on the Unix file system side. And then I'm going to switch over to this tab where I have Metasploit running. And here's that. Remember how I mentioned that JCL, you can just submit JCL jobs on FTP and they'll run? Well, this will do that and give me a shell. So I'm just going to run this handy dandy little Metasploit module. So options here. I've set all the options. So it makes a little JCL card. It puts some BS and all the fields and stuff like that to make it run. So I'm going to go ahead and submit that. Run. Start a reverse TCP handler. Successfully connected. All right, so I have a mainframe Unix session. So there I run ID, and I can see my Unix ID. I can run past print working directory. See there, I don't really have anything in my home directory except a shell history file. So what I'm going to do is a classical tactic, which is when you're on a box and you're looking to privest, I'm just going to run find, and I'm going to look for everything with set UID permissions on it. So I'm going to run that, and I'm going to see some stuff come back, some new things. Well, here's an interesting one. Now, this isn't accurate. I did this for the purpose of demonstration, but the find binary actually has set UID permissions. It runs in a root context no matter who's using it. So I did that just for the purpose of demonstration. So I'm just going to do an old trick you find that if you've seen it before, if like people let people run find with sudo or something, you can abuse that to give yourself an elevated shell. So I'll run the find command, yada yada, I'll tell it to execute, bin/sh to give myself a shell. And there, now I have a shell now I'm still as Eve, but you can see I have the extended UID as 0, which in this context they call it start2 or sys1 instead of root, but it's UID 0, so it's root. Now I can just run the su command and then give myself like proper root. So I run ID again. You can see that that's my proper UID now as I'm start2 in this context. Now I'm going to run SSH keygen. And I'm going to fast forward a little bit because this was an emulated mainframe and it took a long ass time for an SSH key to generate. Okay, there we go. Okay, so I was asking me what I want to name it, so I'm going to give it a name. Freaking eventually. I must have got to get a beer at this point or something. Okay, what do we want to name it? Alright, let's fast forward now. Oh, what I was doing here. Okay, there we go. Okay, so I'll tell it to save it here as key. Yada, I didn't give it a password. I just saved it. So there, ls, now see I have my key file, so I have my key and then my public key. So one trick here is that a lot of times sysprogs, even though sysprogs usually have SU permissions and can just SU the root, they're so lazy that on the Unix side, they'll just give themselves the UID of 0 so that they don't even have to use SU. So in this instance, it's very easy. Now, if I've done some recon and I know what usernames in the mainframe map to which users, I can figure out, okay, I know that Bob Smith is a sysprog and I know what his username is. So I know if I go get him, I'll probably, I'll be maybe the root on the Unix side. But a lot of times they make it easy for you because you just use that rec script I showed before that prints all the Unix users, and you just look for all the guys that have 0 as their UID. Because I'll have multiple of them, we'll just set it to 0. So there we go. I pulled down my keys. Oh, hold on here. Did I do it already? Okay, yeah, I pulled down the keys here. Now, I'm going to CD into Bob's directory, because I know Bob's a sysprog. So I'm going to CD into his SSH directory. There again, old backdoor trick. This is my sole contribution to mainframe hacking. This was actually a technique that neither Phil Rickensrud or Phil Young or Chad Rickensrud or any of those guys knew about. So he has his authorized keys. He's got his public key in there so that he can use his key file to SSH into the mainframe. And so I'm just going to take my public key and add it to his authorized keys. There we go. I'll cat that, make sure it wrote correctly. There, it's all appended on. Very deep in there. Eventually I'll get out. There we go, okay. So I exited out of that session. Now I'm going to go back to SSH. I'd already pulled down that key file with FTP. So I'll set the permissions on that key file correctly so that SSH doesn't yell at me. And now I'm going to SSH in, use that key file, and I'm going to do Bob at the IP address of my mainframe. And bam, I'm in as Bob. Not only that, but Bob has special permissions. See, special and operations, meaning he can change any permissions and he can do any file operation. So Bob is God over on the MVS side. And now I just got access to that without having to know Bob's password. So here I can list out Eve's stuff. Now I see Eve has no attributes. She does not have special or operations. She's just a lowly, nobody. But what I can do is I'm going to run a little file here, a little post-exploitation shell script. And if you can see my comment, I said it's because I'm too lazy to memorize all these commands. So this is just a shell script that's just going to run the TSO command and do a bunch of stuff to give Eve all these elevated permissions. So it finishes. And now if I run TSO command, LU, Eve, now I see that she does have special permissions and everything right there. So now Eve has access. Also part of that script, I gave Eve the ability to log in over TSO. So I'll go back to, to log into TSO. So I'll go back to TN3270, now enter Eve's password, and now she can jump right into the mainframe. And that's it. Ta-da! All right. Oh, and if anybody's wondering, my background is from an anime called Sword Art Online, which it's about like a online video game or something. The computer that runs the video game and the anime is modeled after an IBM Z mainframe. So how can I start learning about mainframes other than attending this talk? First thing you're going to need is you're going to need your own mainframe. So if your company will let you do it, use their mainframe. If not, IBM actually offers an official mainframe emulation package called ZD&T. It is unfortunately very expensive, and it's more so if you're not an IBM customer, which is why unfortunately my company can't afford it. We're not IBM. We don't buy anything from IBM, and it would just be prohibitively expensive to start a contract with them. But if you're at a company that does, and you just kind of research, it's not too bad if you're already in a contract. There's also the IBM Master of Mainframe competition, which I showed you. It runs most of the year. It's made for students, but you can register. Anybody can register. You just won't be eligible for like the prizes and stuff they give out. And it operates most of the year. There'll be a few months when it'll go down, and then they'll have to re-register, and they'll bring it back up. You can't hack on it, but it's a nice way just to get on, and they have some nice tutorials. They'll just teach you how to use the mainframe if you just want to familiarize yourself with it. I also recommend just using the Unix side if you're just more accustomed to Linux. It's an easier way to kind of ease into the mainframe because you won't get lost so quickly. Another option is you can use Hercules, which is an open source mainframe emulator. IBM hates Hercules, as my little meme over there shows. Now, the guy that he's not the guy who first wrote it, but the current maintainer is Jay Maynard, who old internet heads will remember as Tron Guy. I think he's still around going to conventions and stuff. He's the main maintainer of the Hercules project. IBM kind of has a reason to hate Hercules. I guess IBM employees are forbidden to use it. And part of the reason is because the original guy that wrote Hercules tried to set it up as a company. And then what he tried to do is he tried to sue IBM into open sourcing ZOS so that he could undercut their business by offering virtualized mainframes for cheaper. And so he lost his lawsuit, and IBM hates Hercules with a passion. So the legal way is, because mainframes are so old, there are actually versions of the old MVS operating system that have lapsed into the public domain. And there's a couple of hobbyist distros of them floating around, like TK4- is a very popular one that you can run it. MVS is public domain, but a lot of the stuff in it isn't. So they've had to write replacements for ISPF and some of the programs and stuff like that. But it's another good way to if you just want to familiarize yourself with it or run your own. The not so legal way is to go on a torrenting site like Pirate Bay, like Anaconda used to run, and find yourself a dump of a legit ZOS install. They're still floating around there. Honorable mention goes to zos.efglobe.com, which is some strange company based in Canada and China that has a public mainframe you can get access to. I've never really used it, but I'll just throw it out there if you want to fool with it. The next thing you'll need is a terminal emulator, which you have a couple options. The one I use the most is X3270. There's also C3270, which will run in a terminal, and it'll run on Linux, Mac. It'll run inside WSL and Windows. There's paid options for Mac and Windows too. There used to be another free one called TN3270X for Mac, but it just lapsed out of support because Catalina, the newest version of Mac OS, finally got rid of support for 32-bit binaries, and this old TN3270X program hadn't been updated since 2013, so it doesn't work anymore. But X3270 works great. You just need to download Xports and get that set up. And actually, Vista TN3270 is a nice little program. You can actually use it for free with a student license if you sign up for Master of Mainframe. You get a student license to use it. And then if you want some more resources, here's some other great stuff. Obviously, my blog has some things. Master of Mainframe, there's links to the tutorials and how to register. IBM has tons of their documentation and stuff online. You can download PDFs of their Red Book series, which will give you lots of introductions to the mainframe. If you want to continue your mainframe hacking learning, I would highly, highly recommend Phil Young and Chad Rickenrud's Evil Mainframe course. I went to the very first one that they offered in Charlotte, and it's been done at DerbyCon. They do it in other places. It's great. It's a really fun course. They even have a mainframe CTF at the end, which I really dig. And then they also have, you can read a lot of the online material on their GitHub page. They have the slide deck on there, so it's no replacement for going to do it in real life with stuff, but if you want to just learn some of their techniques, it's a quick way. And then for fun, go on archive.org. Phil is also a big dork for old hardware and old computers. He built a choose your own adventure mainframe hacking game in HyperCard running on like Macintosh like System 6, and it's running like on an emulator. You can go play it on archive.org, or you can actually download the file and like run it in like an old Macintosh emulator, like Mini VMac. And that's a real fun one. He's also a big dork for like old operating systems and stuff, so that's a fun little way to play around with it. Big thanks to those guys, Phil and Chad, who helped me out a lot with these slides, and I talked to them in a Slack chat a lot and learned lots of cool things from them. Austin Robertson is another guy I want to thank, who's a former coworker of mine at Fidelity Investments. He was a mainframe return pen tester, and he taught me a lot of cool stuff about mainframes. Shout out to Yuval Saul and Dominic White, who've done tons of great Kix research. Thank you to ISSA Kentuckiana for bringing back the Louisville Metro Infosec Conference, and thank all of you for attending. And if there's any time left, I'm available for any questions anybody has. Sorry, I know I probably talked really fast through that, but I just a lot of stuff to get through. All right, thanks everybody.